Imagine discovering a cosmic time capsule from the ancient galaxy, older than our entire solar system. On July 1, 2025, astronomers spotted something extraordinary racing through space at an incredible 137,000 miles per hour. This wasn't just any ordinary visitor, it was 3I Atlas, the third confirmed interstellar object ever detected, carrying secrets from a part of the galaxy we've never seen before. Discovery of 3I Atlas. What if I told you that finding an interstellar visitor requires watching the entire sky every single night? That's exactly what happened when the Atlas Survey Telescope in Rio Hurtado, Chile, made astronomical history. On July 1, 2025, this powerful sky scanner detected a faint moving object with the temporary designation A11PL3Z. Initially appearing as just a magnitude 18 point of light, the object was traveling through the border regions of constellations Serpens Cauda and Sagittarius. What made astronomers immediately suspicious was its peculiar motion, moving far too fast for any ordinary solar system object. The discovery observations were quickly submitted to the International Astronomical Union's Minor Planet Center, but follow-up observations from both professional and amateur astronomers around the world revealed something extraordinary. This wasn't bound by our sun's gravity at all. Within hours of the initial detection, telescopes across multiple continents were tracking this mysterious visitor, confirming that humanity had discovered another piece of the cosmic puzzle from beyond our solar neighborhood. The object's unusual path through space immediately suggested it originated from outside our solar system, making it only the third confirmed interstellar visitor in human history. Atlas Survey System. Ever wondered how we can monitor threats from space across the entire globe? The Asteroid Terrestrial Impact Last Alert System represents one of humanity's most ambitious skywatching projects. This network consists of 4 50-centimeter telescopes strategically positioned around the world in locations including Hawaii, Chile, and South Africa. Each telescope boasts an impressive 7.4-degree field of view, about 15 times the diameter of the full moon, allowing them to scan vast areas of sky in single exposures. The system operates with military precision. Each telescope surveys 1/4 of the observable sky 4 times per night at approximately 15-minute intervals. With 110 megapixel CCD cameras, these robotic sentinels can detect objects as faint as magnitude 19, while automatically tracking moving objects across multiple observations. The Chilean facility that discovered 3I Atlas represents the cutting edge of this technology, capable of processing thousands of astronomical images nightly, while automatically flagging potential threats or unusual visitors. This automated detection system has revolutionized our ability to spot cosmic wanderers before they disappear back into the darkness of interstellar space. The network's sophisticated algorithms can distinguish between asteroids, comets, and potentially dangerous objects within minutes of detection, providing crucial early warning capabilities for planetary defense. Object classification and naming. Have you ever witnessed the moment when a mysterious space object transforms from unknown to historically significant? The journey from A11PL3Z to 3I Atlas tells a fascinating story of modern astronomical detective work. Initially, when the object was first spotted on July 1, 2025, it received the temporary designation A11PL3Z, following standard protocols for newly discovered moving objects. Within just 24 hours, observations on July 2, 2025 by multiple observatories including the Canada-France-Hawaii Telescope and Lowell Discovery Telescope revealed something crucial: a faint coma and 3 arcsecond tail. This discovery immediately elevated the object's status from potential asteroid to confirmed comet, fundamentally changing how scientists would study and classify it. The Minor Planet Center then bestowed upon it the prestigious designation 3Y Atlas, where 3I signifies it as the third confirmed interstellar object ever discovered by humanity. Simultaneously, it received the official cometary designation C/2025N1 according to international naming conventions. By the time this announcement was made, astronomers had already collected 122 observations from 31 different observatories worldwide, demonstrating the unprecedented global coordination required to track these elusive cosmic visitors. The rapid classification process highlighted how modern astronomy has evolved to quickly identify and study these rare interstellar objects before they vanish forever. Orbital characteristics. So what does it actually take for an object to completely escape the gravitational grip of our solar system forever? Well, 3I/Atlas possesses orbital characteristics that are honestly nothing short of extraordinary, placing it among the most extreme objects ever studied. Racing through space with a hyperbolic excess velocity of 58 kilometers per second relative to the Sun, this interstellar visitor moves significantly faster than both previous interstellar objects, 1I/Oumuamua at 26 kilometers per second and 2I/Borisov at 32 kilometers per second. Its trajectory follows an extremely hyperbolic orbit, with an orbital eccentricity of 6.141, which is the highest ever recorded for any confirmed interstellar object in human history. This extreme eccentricity makes the comet's path appear almost perfectly straight rather than curved, at least when you look at it from our solar system. 3I/Atlas will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units, so that's roughly 203 million kilometers away. Thankfully, Earth remains completely safe during this encounter, as the comet will never approach closer than 1.8 AU to our planet. After its solar encounter, this ancient visitor will continue its relentless journey back into the vast emptiness of interstellar space, carrying with it the gravitational signature of its dramatic passage through our solar system for, well, billions of years to come. Physical properties. So, how do you measure something that's surrounded by a cloud of gas and dust, millions of kilometers away, out there in the depths of space? Determining 3I/Atlas's physical characteristics actually presents some pretty unique challenges, mostly due to its active cometary nature, and all the interference from its surrounding coma. Early estimates suggest the nucleus diameter ranges somewhere between 0.8 to 11 kilometers, though astronomers tend to favor the lower end of this range based on brightness measurements and activity levels. The Gran Telescopio Canarias made a crucial breakthrough between July 2nd and 5th, 2025, determining that the nucleus rotates with a period of 16.79 hours. The brightness variations are only 0.2 magnitudes, which actually suggests a relatively round shape. Color observations using the Palomar 200-inch telescope on July 3, 2025, revealed some fascinating details about its surface composition, a GR color index of 0.43 magnitudes, RI of 0.16 magnitudes, and a spectral slope of about 1.3% per 100 nanometers. The comet's absolute magnitude measures approximately 12, which corresponds to a nuclear radius of roughly 10 kilometers, assuming typical asteroid-like albedo values. These measurements, though, become increasingly difficult as the comet develops a more extensive coma, making it really challenging to distinguish the solid nucleus from all the surrounding ejected material that creates that classic fuzzy appearance. Advanced imaging techniques and computer modeling are being used to separate the nucleus signal from the contaminating coma light. Comet activity features. So what makes 3I/Atlas behave more like 2I/Borisov than the mysterious and inactive 1I/Oumuamua? Unlike the first interstellar visitor, which showed no cometary features whatsoever during its passage, 3I/Atlas actually displays clear signs of vigorous activity even while it's 4.5 astronomical units from the Sun, much farther out than most solar system comets start showing activity. The comet exhibits a distinct fuzzy appearance in telescope images, which indicates a well-developed coma, a cloud of gas and icy dust particles ejected from the nucleus surface as solar radiation heats up volatile materials. Spectroscopic observations by Gemini South and the NASA Infrared Telescope facility on July 5 and 14, 2025, confirmed that the coma contains water ice and silicate grains with radii of about 10 micrometers. The dust cross-section within 10,000 kilometers of the comet measures 230 square kilometers, assuming an albedo of 0.10. As solar heating intensifies the sublimation process during its approach, micrometer to millimeter scale particles are ejected at speeds ranging from 0.01 to 1 meter per second, resulting in a dust mass loss rate of 0.1 to 1.0 kilograms per second. This activity level suggests the presence of highly volatile ices that have remained frozen for billions of years, potentially preserving ancient chemical signatures from its original star system. Amateur contributions. So, how did citizen scientists around the world help unlock the secrets of this remarkable interstellar visitor? Well, the discovery and characterization of 3I Atlas marked a historic milestone for amateur astronomy communities worldwide. It really shows how modern technology has, democratized space exploration in ways we couldn't have imagined a few decades ago. Let me tell you about Vamshi Kesareddy, a dedicated citizen astronomer. On July 4, 2025, he achieved something pretty remarkable by successfully capturing 3I Atlas using a unistellar telescope and measuring its brightness at 17.8 magnitude. This observation potentially represents the faintest object ever detected by the unistellar network, which just goes to show the incredible capabilities of modern citizen science equipment and automated imaging systems. And there's more. Amateur astronomer Sam Dean made some crucial contributions too, by meticulously identifying additional Atlas prediscovery observations from June 5th to the 25th, 2025. This extended the observational arc and really improved the orbital calculations. Meanwhile, the Las Cumbres Observatory Network, using 0.36-meter telescopes at Haleakala and the 2.0-meter Falks Telescope North, provided essential photometric data. They showed light curve variations of less than 0.2 magnitudes over a 29-hour time span. All these amateur contributions proved absolutely invaluable, as 3I Atlas traveled through star-crowded fields near the galactic center. In fact, professional surveys might have missed it entirely, because the dense stellar background creates confusion in automated detection systems. So it's clear that the passion and dedication of citizen scientists are, honestly, making a real difference in our understanding of the cosmos. Surface composition. So, what can the colors and reflected light from 3I/Atlas actually tell us about its ancient origins in a distant star system? Spectroscopic analysis, reveals some fascinating details about this interstellar wanderer's composition and the environment where it formed billions of years ago. Observations using the Very Large Telescope on July 4th and 5th, 2025, didn't detect clear signs of hydroxides and cyanides gases in the coma, placing upper limits on outgassing rates of about 8.2 times 10 to the 26th molecules per second, and 5.6 times 10 to the 23rd molecules per second, respectively. However, the comet's red spectral characteristics did show up in multiple independent observations, with a spectral slope measuring 18 plus or minus 4% per 1,000 angstroms, making it significantly redder than most solar system comets we've studied. The water ice and silicate mineral composition, detected through infrared spectroscopy, suggests a pretty typical cometary makeup, but the comet's distance from the sun during those early observations meant that many volatile compounds stayed frozen solid. Scientists predict that carbon dioxide and carbon monoxide ices are likely present within 3I/Atlas, though these substances haven't yet been detected as gas emissions. Future observations by the James Webb Space Telescope will provide more detailed compositional analysis as the comet gets closer to the sun and becomes more active, potentially revealing the pristine chemistry preserved from its formation environment. Interstellar object density. So just how common are these cosmic visitors from beyond our solar system wandering through the galaxy? The discovery of 3I/Atlas actually provides crucial insights into the population density of interstellar objects that have been ejected from their parent star systems and now drift through the vast spaces between stars. Based on 3I/Atlas's characteristics and the circumstances of its detection, astronomers calculate a spatial number density of approximately 1 in 1,000 objects per cubic astronomical unit for objects with radii greater than or equal to that of 3I/Atlas. This means that within a cube of space measuring 1 astronomical unit on each side, we might expect to find about 1 object of 3I/Atlas's size or larger every 1,000 such volumes throughout local interstellar space. The rapid succession of interstellar discoveries, first one I/Oumuamua in October 2017, then 2I/Borisov in August 2019, and now 3I/Atlas in July 2025, suggests these objects may be far more common than previously thought by theoretical models. Statistical models now indicate that millions of such objects likely pass through the outer solar system undetected each year, basically invisible to our current detection capabilities. The Atlas network's improved sensitivity and comprehensive sky coverage now mean we're finally reaching the detection threshold necessary to regularly spot these ancient wanderers from distant stellar neighborhoods. Origins and age speculation. Could 3I/Atlas actually be older than our entire solar system, carrying materials from the early galaxy? The comet's extreme velocity and unusual trajectory provide some tantalizing clues about its ancient origins in a very different cosmic environment. Moving at 58 kilometers per second relative to the Sun, 3I/Atlas likely originated from the Milky Way's thick disk, which is a region populated by older stellar populations that formed when the galaxy was younger and chemically different. This suggests the comet could be at least 7 billion years old, which is significantly older than our 4.6 billion-year-old solar system, and potentially containing pristine materials from the early galaxy. The thick disk connection indicates 3I/Atlas formed around low metallicity stars that existed when heavy elements were much rarer throughout the cosmos. Its high velocity suggests it was violently ejected from its parent system through dramatic gravitational interactions, possibly involving massive planetary bodies or close stellar encounters that flung it into interstellar space. The comet's water-rich composition and early activity patterns support theories that it formed in the outer regions of an ancient planetary system, where volatile ices could condense and survive for billions of years in the cold depths of space. This cosmic time capsule really offers an unprecedented opportunity to study materials that predate our solar system's formation. As 3I/Atlas continues its epic journey toward the Sun, reaching closest approach on October 29, 2025, it carries with it secrets from the ancient galaxy that we're only beginning to unlock. This remarkable visitor reminds us that space is filled with wandering worlds, each telling a unique story of cosmic evolution. For more mind-blowing space discoveries that challenge everything we thought we knew about our universe, make sure to like, share, and subscribe to Space Facts, where the cosmos reveals its greatest mysteries. A Harvard scientist is sounding the alarm. An interstellar visitor, 3I/Atlas, is shedding metallic alloys that just shouldn't exist. Real data from our best telescopes shows atomized nickel streaming from its core, but with practically zero iron. A chemical fingerprint that really defies everything we know. Harvard's Avi Loeb is asking the question no one else wants to: if these metals aren't natural, what does that mean? The answer could upend our place in the universe, so let's explore this together. The discovery of 3I/Atlas. What would you do if you saw something moving at 130,000 miles per hour that wasn't supposed to be there? On July 1, 2025, the Atlas survey team in Chile spotted a faint, fast-moving speck. The math instantly told a story that just didn't fit any known playbook. Its path wasn't just a long loop, it was hyperbolic, with an extreme eccentricity that confirmed it was a visitor from deep space, moving too fast for the Sun to ever capture it. This wasn't a comet on a return trip. Astronomers combed through archival data and found earlier images, firming up its trajectory. The object was born far beyond our solar system, possibly somewhere near the galactic center. By the time it was discovered, it was already inside Jupiter's orbit, making a one-time slingshot around our Sun before it shoots back into the void. Its incredible velocity confirmed it. 3I/Atlas is only the third confirmed interstellar object ever seen, a messenger from another star that will never return. This isn't just a rock, it's a clue from an unknown part of the galaxy. The nickel mystery. Imagine finding a fingerprint that doesn't match any person on Earth. That's what astronomers found in the light from 3I/Atlas. Almost as soon as it crossed Jupiter's orbit, spectrographs detected strong signals of atomic nickel streaming from its coma. But the real shock wasn't what was there, it was what was missing. There was virtually no iron. This isn't just unusual, it's chemically bizarre. In every meteorite and comet we've ever studied, nickel and iron are cosmic partners, forged together in the hearts of dying stars and locked into the same minerals. When a comet heats up, they should be released together. Yet, data from the Very Large Telescope showed nickel vaporizing off the object, while iron was a no-show. Harvard astrophysicist Avi Loeb was the first to publicly highlight how unnatural this is. He argues that separating nickel from iron requires industrial processes here on Earth. In space, it's unheard of. It's like finding a gold ring without any trace of the other metals typically alloyed with it. This single chemical clue is so potent that it forces a profound question. Are we witnessing a freak of nature, or is this a deliberate engineered signature? Carbon dioxide dominance. Just when the nickel-iron problem had scientists scrambling, the James Webb Space Telescope delivered another bombshell. Pointing its powerful infrared instruments at 3Y Atlas, a team of astronomers analyzed the gases in its coma and found that carbon dioxide was completely dominating the mix. The measured carbon dioxide to water ratio was a staggering 8-to-1, the highest ever recorded for any comet, whether from our solar system or beyond. To put that in perspective, typical solar system comets have CO2 levels around 4% of their water content. Here, CO2 is the main ingredient. This wasn't a fluke. The readings remained consistent across multiple observation sessions as the object neared the sun. While other gases like carbon monoxide were present, nothing came close to the CO2 spike. This kind of chemistry just doesn't align with our models of comet formation. Some researchers propose that its unique composition is the result of being cooked by cosmic rays over a billion-year journey. Others wonder if it's a clue to the specific conditions of its home star system. But the question remains, does this unprecedented chemistry point to nature at its most extreme, or is it another sign that something else is at play? The Oumuamua precedent. This isn't the first time an interstellar visitor has broken all the rules. Back in late 2017, astronomers detected one Oumuamua. At first it seemed like an asteroid, but its behavior was deeply strange. As it swung past the sun, it began to accelerate, pushed by a force that wasn't gravity. The problem? There was no visible outgassing, no tail, no coma, none of the typical rocket-like effects a comet uses to speed up. Oumuamua left nothing behind. Its light curve also suggested a bizarre shape, perhaps 10 times longer than it was wide, like a cigar or a flat pancake. The scientific community scrambled for an explanation: exotic ices, hydrogen outgassing, fractal dust. But no single natural theory fit all the data. It was into this debate that Harvard's Avi Loeb stepped, arguing that Oumuamua's shape and acceleration were consistent with an artificial object, specifically, an ultra-thin solar sail designed to ride the pressure of starlight. The idea caused a firestorm, but it cemented a critical precedent. When objects from other stars arrive, we shouldn't assume they'll play by our rules. Oumuamua prepared the scientific world to ask bolder questions. Ancient sky metal. Humanity's fascination with metals that fall from the sky is not new, it's ancient. Over 5,000 years ago in ancient Egypt, craftsmen hammered tiny beads from a mysterious iron that they didn't mine from the earth. Modern analysis of these beads from the Giza cemetery reveals a nickel content of nearly 30%, far higher than any terrestrial ore. This was the unmistakable signature of meteoritic iron. The story gets even more incredible with the dagger found in the tomb of King Tutankhamun. Discovered in 1925, the pristine iron blade was a mystery for decades. Finally, X-ray analysis confirmed its celestial origin. The blade contained 11% nickel and traces of cobalt, a composition that matched iron meteorites. The Egyptians even had a name for this divine material, iron of the sky. It was rarer and more valuable than gold, reserved for pharaohs. This history matters because it establishes a fundamental contrast. Terrestrial iron ores almost never exceed 4% nickel. Meteoritic iron, however, is rich in it. The same questions our ancestors faced, what is this strange metal and where did it come from, are echoing today as we analyze the impossible alloys of 3I Atlas. Kilonova formation theory. So if not aliens, what could possibly create pure nickel vapor in space? The answer might lie in one of the most violent events in the universe, a kilonova. This is what happens when two neutron stars, the ultra-dense corpses of massive stars, spiral into each other and collide. The resulting explosion is so powerful, it forges heavy elements through a process of rapid neutron capture known as the R process. In 2017, the gravitational wave event JWST gave astronomers their first direct look at this process, confirming that neutron-star mergers create vast quantities of heavy elements like strontium, gold, and platinum. nickel is also created in this cosmic furnace. Crucially, depending on the chaotic conditions of the explosion, some models predict that patches of the ejected debris can be exceptionally rich in nickel while being poor in iron. These aren't the slow-cooked metals from normal stars. They are forged in seconds and blasted into space. If 3I Atlas condensed from such a cloud of debris, it would carry a chemical fingerprint completely alien to our solar system. This provides a natural, albeit spectacular explanation for its strange composition. Asymmetric supernova theory. So, there's another natural forge out there in the cosmos, violent enough to potentially explain 3I Atlas's strange chemistry and asymmetric supernova. You see, not all stars meet their end in neat spherical explosions. Some, well, they rip themselves apart in these lopsided blasts that fling elements out in jets. The supernova remnant W49b is a perfect example of this. X-ray maps from the Chandra Observatory show that iron is packed tightly near the remnant's core, while other elements like sulfur and silicon are distributed more broadly. This kind of uneven explosion, it completely changes the rules of how metals are scattered into space. In these chaotic events, the inner layers of the star, where iron and nickel are made, don't mix evenly. Instead, high-speed plumes can punch through the star's outer layers, carrying specific elements with them. And if nickel happens to be concentrated in the path of one of these jets, it can be ejected in bulk, leaving most of the iron trapped behind. So, if 3I Atlas formed from a fragment blasted out by such a supernova, it could have started its journey as a chunk of nearly pure nickel. This provides a second plausible, though very rare, natural path to its bizarre composition. Statistical improbability. Beyond its strange chemistry, the path of 3I Atlas through our solar system is so unusual it's hard to ignore. Avi Loeb and his collaborators ran the numbers, calculating the probability that a random interstellar object would have a trajectory that takes it unusually close to Venus, Mars, and Jupiter, all in a single pass. The result was a probability so small it's almost zero, about 0.005%. That's like flipping a coin 15 times and getting heads every single time. To Loeb, this really strains the definition of coincidence and starts to look like a pattern. The object's path is nearly flat relative to the solar system's plane, but it's moving backward or retrograde against the flow of the planets. This combination allows it to skim past the inner worlds in a way that looks suspiciously like a survey flight. Critics argue that in a vast universe, rare events are bound to happen, but Loeb counters that if the odds are 1 in 20,000, and we've only seen 3 interstellar visitors so far, something doesn't add up. When you combine this improbable trajectory with the engineered-looking metals, Loeb argues it's time to take the artificial origin hypothesis seriously. The Golden Record Parallel. Could 3I Atlas be a message in a bottle? In 1977, NASA launched the Voyager 1 and 2 spacecraft, each carrying a golden record. This was a project led by Carl Sagan, intended as a time capsule for any extraterrestrial civilization that might find it thousands of years from now. The records contain sounds and images of Earth, music from various cultures and scientific diagrams, a snapshot of humanity etched onto a durable physical object. Sagan said, the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. Now consider 3I Atlas, an object loaded with alloys and compounds that don't fit natural recipes on a trajectory that seems too precise. The parallel is striking. What if its message isn't written in grooves on a record, but in the very ratios of its elements? A physical archive designed to survive a journey of millions of years. If its composition is intentional, then 3I Atlas isn't just a visitor. It's a courier carrying a record of another world's chemistry, and maybe even its technology. Atomic messages. What if we've been looking for the wrong kind of message? For decades, the search for extraterrestrial intelligence has focused on radio waves and light signals. But what if an advanced civilization chose to send a message encoded in matter itself? This is the provocative idea that the anomalies of 3I Atlas force us to consider. On Earth, scientists are already developing methods to store information using the ratios of isotopes in molecules, creating a kind of atomic fingerprint that can be read with a mass spectrometer. In biology, DNA stores vast amounts of information in a sequence of 4 chemical bases. Some theorists now wonder if the periodic table itself could be used as a sort of cosmic QR code. By arranging isotopes in a pattern that nature would never produce by chance, a message could be baked into a physical object. This message would be incredibly durable, immune to cosmic noise, and capable of surviving for billions of years. Spectrographs are now re-examining every bit of data from 3I Atlas, looking for these hidden patterns. The hunt is on for a fingerprint that says someone was here, and they wanted to be found. The story of 3I Atlas leaves us at a profound crossroads. On one hand, we may be witnessing an undiscovered violent natural process, a kilonova or an asymmetric supernova capable of creating alloys we once thought impossible. On the other hand, the combination of inexplicable metals, extreme chemistry, and a statistically improbable trajectory has forced serious scientists like Avi Loeb to consider an engineered origin. This isn't just a theoretical debate, it's a real object with real data that is breaking our models of the universe. Either way, our understanding has to expand. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cosmic mysteries. Thanks for watching Space Facts. A cosmic alignment so perfect it defies chance, or a deliberate arrival we were never meant to see. On September 12, 2025, astronomers witnessed the impossible. Two colossal objects arriving from opposite ends of the universe, set to rendezvous in our solar system during a total observation blackout. The official story is twin comets, but the evidence points to something far stranger. Let's explore this together. Swan's dramatic arrival. What if a new object appeared in the sky tonight so large it dwarfed everything we've seen in a generation? That's exactly what happened on September 12, 2025. Data from the Solar Wind Anisotropes or SWAN instrument, a wide-field camera aboard the SOHO spacecraft, revealed a bright, unmistakable object blazing through the solar system. The initial readings were staggering. Its tail stretched nearly 2.5 degrees across the sky, which is about 5 times the width of a full moon. For a newly discovered comet, this scale is almost unheard of. For comparison, the famous comet Hale-Bopp's tail was about as wide at a similar distance. Initial photometry clocked it at a magnitude of 7.4, a brightness level that makes it an easy target for backyard telescopes and even powerful binoculars. The news spread like wildfire, and amateur astronomers scrambled to confirm what the satellite had seen. Just 2 days later, an observer in Australia captured a dramatic image showing a streak of light so immense it barely fit in the camera's frame. The immediate reaction wasn't just excitement, it was disbelief, as the object was already outshining professional predictions by a factor of 4. This was no ordinary icy visitor. The sheer size and luminosity didn't match any recent precedent, forcing comparisons to legendary comets of the past. Official recognition and growing mystery. A name makes it real but can also deepen the mystery. By September 13th, the International Astronomical Union's Minor Planet Center made it official, designating the object C/2025 R2 or SWAN in honor of the instrument that found it. Within a single weekend, the global astronomy community, from professionals using the Hubble Space Telescope to amateurs in their backyards, was completely fixated on this celestial titan. They traded images and brightness measurements across hemispheres, trying to make sense of its unprecedented behavior. Most comets discovered in the modern era are faint smudges requiring powerful telescopes, but SWAN was a spectacle for anyone who knew where to look. Its magnificent tail sliced through the constellation Virgo at a blistering pace of 20 arc-seconds per minute, growing brighter with each passing day as it raced toward the sun. The conversation quickly shifted from simple observation to intense speculation, with astronomers like Dr. Robert Warwick, the discoverer of Oumuamua, noting the statistical improbability of such a bright object appearing with so little warning. The amateur community, often the first to notice unusual behavior, was already debating what could possibly power a tail this long and this bright. It was simply too big, too vivid, and too fast to be ignored. The cosmic coincidence. Some things are too perfect to be random. C/2025 R2 or SWAN wasn't the only newcomer drawing attention. Just days before its discovery, another object, the Interstellar 3I/Atlas, was already on its way in, approaching from a completely different sector of the sky. SWAN's path originated from the direction of Aquarius, while Atlas emerged from Sagittarius. On a star map, their arrival vectors are separated by more than 100 degrees of the sky. And yet, both are scheduled to reach perihelion, their closest point to the Sun, within the same 10-day window in October. Swan will arrive around October 20th at a distance of about 1 AU, the same as Earth's orbit. Atlas will skim past the Sun just 3 days earlier on October 17th, at a distance of roughly 1.36 AU. This puts their perihelion points only about 50 million kilometers apart, closer than Mars ever gets to Earth. Their orbital geometry is just as striking. Both are on steeply inclined paths, with Swan tilted over 60 degrees and Atlas at a near-polar 85 degrees to the plane of our solar system. According to experts like Dr. Paul Chodas at NASA's Center for Near-Earth Object Studies, the odds of two such objects from such different origins, arriving in near-perfect synchrony, are vanishingly small, estimated at less than 1 in a billion. Atlas breaks the rules. So what happens when an object just, flat out refuses to follow the laws of physics as we know them? Well, that's exactly what happened with 3I/Atlas, which first caught astronomers' attention by, honestly, breaking all the rules. Early spectrographs from the Atacama Large Millimeter Array reported something that set off alarms everywhere. A body dominated by nickel with virtually no iron, a ratio that's pretty much unheard of in natural celestial objects. This completely contradicts everything we know about comets and asteroids, which almost always contain iron-nickel blends similar to chondritic meteorites. The claim was so radical, some labs immediately called for data re-verification just to make sure there wasn't some kind of mistake. But the mystery only deepened when its coma was found to be pumping out carbon dioxide, detected at a strong 4.3 micron spectral line, at rates 5 times higher than water. And what really couldn't be explained was its motion. Observers noted 3 distinct, non-gravitational accelerations, each providing a delta V of several meters per second. These weren't the gentle pushes from solar heating, they were sharp, sudden bursts, almost as if the object had fired a thruster. The only other object to show similar acceleration was Oumuamua, but as Harvard astronomer Avi Loeb pointed out, the pulses from Atlas seemed far more controlled and powerful. Swan, the fortress. One object acts like a drone, the other like a battleship. C2025 R2 or Swan is honestly in a league of its own. Its sheer scale is breathtaking, but it's really the finer details that have experts truly puzzled. The first whispers of something strange began with reflectance data showing an unusually high albedo or reflectivity of 0.6, similar to fresh snow. That's wild, considering typical comet nuclei are darker than asphalt, with albedos below 0.05. Some amateur spectroscopists even argue the data matches a nickel-cobalt alloy, a material we use on Earth for its immense strength and resistance to corrosion. This is what led to the term nickel-cobalt hull popping up in online forums. Then came reports of an optical anomaly, a persistent silvery halo around the nucleus that seemed to shimmer. Some experts theorize this could be a plasma envelope or a mini-magnetosphere, acting as an electromagnetic shield. That's actually where the nickname the fortress comes from. Unlike the agile Atlas, Swan moves like a tank, slow, steady, and honestly, seemingly invulnerable. Its record-breaking tail also shows evidence of micro-thrusts, tiny, rhythmic pulses that suggest precision course corrections, which are way too regular to be just random outgassing from surface fissures. Mission theories. Coincidence, or a coordinated mission? When a long-period object on a 22,554-year cycle and a hyperbolic interstellar object arrive together, the odds of chance really start to plummet. This has fueled a whole wave of mission theories. The first, and probably the most routine, is a scheduled refueling run, with the Sun acting as a cosmic pit stop for 2 engineered probes. A second, less peaceful theory, suggests an intervention or a confrontation, especially when you consider the incredible power levels required for their observed accelerations. A third theory, championed by thinkers like Dr. Avi Loeb, proposes an audit chain. Oumuamua, or 1I 2017 U1, was the first scout, followed by 2I Borisov, and now Atlas and Swan represent escalating responses to Earth's century of radio transmissions. Each new arrival would be a more complex probe sent to check in. In every scenario, the Sun isn't just a backdrop, it's the rendezvous point, the power source, and the beacon. The idea of using a star for a gravitational assist or an energy top-up is standard practice for our own probes, like the Parker Solar Probe, which honestly makes this theory chillingly plausible. Ancient connections. Could our history be written in the stars, just waiting for the right moment to be read? Schwann's enormous 22,554-year orbit is, a direct link to the last ice age. Its last visit to the inner solar system would have occurred around 20,000 BCE, a time of immense climate change when human civilization was really in its infancy. This same epoch left its mark in the ice cores of Greenland and Antarctica, where layers of dust hint at dramatic celestial events. At the heart of this idea is Göbekli Tepe, a mysterious site in Turkey built around 9600 BCE. Its stone pillars are carved with symbols, and some of these are interpreted by researchers like Martin Sweatman as depictions of comets. His controversial analysis of Pillar 43, the Vulture Stone, suggests it records a catastrophic comet impact that triggered a mini ice age. Mainstream archaeologists and astronomers strongly caution that these connections are speculative. Still, the timing is, well, hard to ignore. Schwann's last passage happened just as human culture was taking its first steps toward tracking the heavens and building monuments, leaving open the tantalizing possibility of a forgotten history. The blackout window. Just as things get interesting, the lights go out. From October 8th to 18th, both Schwann and Atlas will pass through solar conjunction, meaning the sun's glare makes them impossible to observe for optical telescopes on Earth. This affects every major observatory, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, as the objects will be within a solar elongation angle of fewer than 5 degrees. This is a normal astronomical occurrence, but the timing is incredibly convenient. Rumors are circulating of internal memos from agencies like US Space Command and the European Space Agency, directing teams to suspend high-resolution imaging. Proposals for alternative observation methods have allegedly been denied, and raw data requests delayed. A handful of telescope allocation reviewers, speaking off the record, have described explicit orders to avoid public statements. The result is a forced silence at the exact moment when the two most anomalous visitors in modern history make their closest approach, leaving a frustrating and highly suspicious gap in the data. Underground resistance. When official channels go dark, the people light the way. The observation blackout may have silenced government agencies, but it sparked a fire in the global community of independent astronomers. Bill Gray, a veteran tracker renowned for his open-source orbit calculations, rallied a distributed network of backyard observers and small observatories. His call to action spread across forums with a clear message: keep your scopes on the sky, log every flicker, and share the raw data. In Europe, amateur collectives began pooling wide field sensor feeds, while leaks from private groups suggested makeshift plans to bypass the blackout using radio telescopes, like the Allen Telescope Array, hoping to detect emissions from the objects themselves. With big institutions locked down, this grassroots effort, relying on publicly available data from surveys like the Zwicky Transient Facility, has become the only real-time source of information. It's a testament to the power of citizen science. If we're going to get answers, they might just come from someone's backyard, not a government lab. Power estimates and implications. Let's talk about the energy because the numbers are staggering. The biggest red flag for both objects is the power source required to explain their behavior. If the observed accelerations of Atlas are indeed powered by thrusters, the energy output would need to be on the order of 10 gigawatts. That's the equivalent output of 10 large nuclear power plants, like the Palo Verde generating station. But Schwann makes that number look insignificant. Based on its size, brightness, and the micro-thrusts detected in its tail, the most extreme estimates place its power output at a mind-boggling 10,000 gigawatts, or 10 terawatts. That is more raw power than the entire energy grid of planet Earth combined. From a physics perspective, as noted by futurists like Dr. Michio Kaku, such energy control would place its creators firmly on the Kardashev scale as a Type 1 or even Type 2 civilization. These figures push the conversation beyond academic debate and into a realm that forces us to question everything we thought we knew about our place in the universe. Here's the bottom line. Two of the most anomalous objects ever detected have entered our solar system on a synchronized path. Their composition and behavior defy our current understanding of comets, and their arrival coincides with an official observation blackout that has silenced the world's most powerful telescopes. We are left with a grassroots network of citizen scientists working to uncover the truth and energy readings that point not to nature, but to technology. Whether this is a cosmic coincidence, a peaceful rendezvous, or something else entirely, we may soon find out when they emerge from the sun's glare. The only question left is, what will we see when they come out the other side? Don't forget to like, subscribe, and hit the bell icon for more updates on this developing story. Thank you for watching Space Facts. What if the most profound discovery in human history was made, and then deliberately buried? We're not talking about rumors or grainy photos. We're talking about 24 gigabytes of classified NASA data on an interstellar visitor that defied the laws of physics. Data leaked by a ghost-like hacker group, revealing a 26-kilometer-wide object that wasn't just passing through our solar system, but actively navigating it. This is the story of 3I Atlas, what NASA allegedly found and why they never wanted you to see it. Let's delve into the data. Event Horizon cyber attack. How does a secret stay buried in the digital age? Sometimes, it doesn't. In the dead of night on September 2nd, 2025, a hacker collective calling themselves Event Horizon executed a flawless cyber attack on NASA. They didn't just knock on the door, they dismantled it. By exploiting a zero-day vulnerability in an outdated mission planning module, they bypassed layers of federal firewalls. Security logs, later leaked themselves, show a terrifying timeline. At 3:14 a.m. Eastern, initial access was gained. By 3:19 they had escalated their privileges to the highest level. At 3:23, the exfiltration began. In less than 7 minutes, 24 gigabytes of compressed files were siphoned from a secure server containing mission telemetry, internal communications, and top-secret analysis on Object 3Y Atlas. By 3:30, they were gone. The attackers left no signature, no digital fingerprints, only a silent void in the server logs where critical audit trails should have been. The specific target was a data archive tied to the Deep Space Network, containing the most sensitive raw telemetry. NASA's internal cyber forensics team was left with nothing but a clean exit, a ghost in the machine that had walked out with the crown jewels. The manifesto and distribution. A data breach is one thing, but a declaration of war on secrecy is another. Within hours of the hack, a manifesto from Event Horizon appeared on encrypted forums. Their message wasn't a boast, it was a justification. They claimed the breach was a direct response to what they termed unlawful cosmic secrecy, arguing that discoveries of this magnitude belong to humanity, not to a select few government agencies. The manifesto warned that the stolen files contained information so sensitive even senior directors at NASA were allegedly unaware of its full scope. Their language was direct: the world deserves to know what its own scientists have found. To prove their point, they began a strategic distribution campaign. Blurred screenshots and heavily redacted memos were sent to journalists and channels known for covering classified science. They specifically avoided mainstream outlets, opting for platforms that would analyze the data without an institutional filter. This drip feed of information created a groundswell of speculation that legacy media couldn't ignore, forcing the conversation into the open on Event Horizon's terms. Authenticating the documents. How can we be sure these leaks are real? The proof is in the details. The screenshots that flooded encrypted channels are layered with evidence of their origin. Documents are stamped confidential in bold block letters. Metadata tags show a 0314 UTC timestamp, matching the breach window from NASA's own security audit. A mission patch appears in the corner, a stylized comet streaking past a NASA vector, flanked by the code 3I Atlas int. One partially blurred memo lists the object's trajectory with terrifying numbers, hyperbolic v-infinity of 26.1 kilometers per second and an eccentricity, or E, of 6.2. These figures confirm an interstellar origin at a speed that defies simple explanation. Another screenshot shows a status log from the intercept team. Most text is blacked out except for a single phrase: plume anomaly flagged at T plus 11.3 seconds. The documents include FITS file headers for raw imaging data and internal routing codes for JPL's document management system. These are the kinds of mundane, technical details that are nearly impossible to fake convincingly. Discovery of 3I Atlas. Before the leak, there was the discovery that started it all. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, or ATLAS survey in Hawaii, logged a new object tearing into the solar system at 130,000 miles per hour. Astronomers flagged it immediately. This was no ordinary comet. The object, soon labeled 3Y Atlas, measured an estimated 26 kilometers across, roughly the size of Manhattan, moving faster than any object ever observed inside the orbit of Jupiter. Veteran survey scientist Dr. Lina Takahashi, a fictional name from the leaked files, was quoted in a log. The track was so steep, the software flagged it as an error. Within hours, observatories from Chile to Arizona confirmed the numbers. The object's incoming speed of over 58 kilometers per second defied the sun's gravitational grip. Its trajectory pointed back toward the constellation Lyra, far from the ecliptic plane where most solar system debris resides. To put its size in perspective, the asteroid that killed the dinosaurs was only about 10 kilometers wide. This was over twice that, and it wasn't from around here. Impossible physics and trajectory. Here is where the data gets terrifying. The trajectory of 3I Atlas was not just interstellar, it was unnatural. Calculations from the Minor Planet Center confirmed by JPL revealed an orbital eccentricity of over 6. For context, most comets from our own Oort cloud barely reach an eccentricity of 1.0. Our first interstellar visitor, Oumuamua, had an eccentricity of 1.2. A value of 6.2 means the object was moving on an almost perfectly straight line at a velocity that gravity could barely alter. But the most damning piece of evidence detailed in the leaked mission logs was a sudden, unexplained sideways acceleration on July 18, 2025. It was a course correction. The object wasn't just flying, it was steering. The maneuver required a change in velocity, or delta V, that would have required gigatons of force to achieve on an object of this mass. All natural explanations, outgassing, solar radiation pressure, even a gravitational assist from an unknown planet, were systematically modeled and ruled out by JPL's top analysts. The physics simply didn't work unless the push came from within. Surface anomalies. The armor problem. What does a 26-kilometer object from another star system look like? The first leaked images from the Intercept mission were paradigm-shattering. 3I Atlas's surface resembled no comet on file. Imaging analysts flagged a pattern of smooth, almost metallic-looking plating, broken by lines that ran too straight to be natural fractures. One analyst, quoted in a redacted chat log, called it the radiator problem, referring to a gridwork of raised ridges spaced like the cooling fins on spacecraft. These ribs cast long uniform shadows, and their regularity caused the anomaly detection software to flag the pattern as artificial. Comparisons to known comets like Halley or 67 P Churyumov-Gerasimenko fell apart. Their surfaces are jagged and chaotic. 3I Atlas, in contrast, had long stretches that reflected sunlight like polished alloy. Further spectral analysis of this reflected light showed an albedo inconsistent with any known meteoritic iron, lacking the usual chondritic features. It was too smooth, too reflective, and far too structured. Thermal signatures and heat pulses. This is where the data points directly to active technology. Martin Cordner's team at Goddard Space Flight Center, a name appearing in the leak, got a full infrared spectrum of 3I Atlas. The data was so sensitive it was sealed within hours under a restricted embargo. The logs show the Webb Telescope's infrared array recorded heat vents pulsing with the regularity of a clock every 90 seconds. Heat would pool along the radiator seams and then burst outward in tight, directed jets, not the broad, chaotic outgassing of a comet. The mission logs label this a directive motion event, a term usually reserved for spacecraft thrusters. More disturbing, trajectory analysts correlated these thermal pulses with the object's subtle course corrections. Each 90-second heat pulse matched a tiny, precise adjustment needed to maintain its hyperbolic escape route. The focused nature of these thermal events implies the existence of engineered nozzles or vents, as a natural body's heat would dissipate uniformly across its surface according to the laws of thermodynamics. This was controlled, focused, and undeniably artificial. Chemical composition mysteries. The mystery only deepens when you look at what 3I Atlas was made of. Martin Cordner's team at Goddard was the first to get a full spectrum after the Intercept, and the results were an instant red flag. The early spectra lit up with incredibly sharp, bright lines of nickel. In cosmic bodies, nickel almost always rides shotgun with iron. Yet in every single frame of data from 3I Atlas, iron was almost completely absent. Its signature spectral lines were missing. This isn't just rare. In the entire catalog of known comets and asteroids, it's unheard of. The natural formation processes that create asteroids from protoplanetary disks simply don't separate these two elements with such purity. Leaked notes suggest the isotopic ratio of the nickel was also wrong, indicating it wasn't formed in a typical supernova. The purity level was estimated to be over 99.8%, a level that on Earth requires an advanced electrochemical process known as the Mond process. Radio echoes and communication patterns. Did we ever try to listen? According to the leaked files, yes. And what we heard was terrifying. While public-facing projects might report silence, the classified logs from the Deep Space Network told a different story. Radio astronomers reviewing the intercept mission's raw data flagged a pattern that shouldn't have been there, faint, repeating echoes bouncing back from the object at regular intervals. These were not natural radio bursts or cosmic static. They were precise, clipped signals echoing at intervals that mapped almost perfectly to the 90-second timing of the object's thermal pulses. A veteran telemetry specialist named Marissa Singh, in a chat log later leaked by Event Horizon, wrote, "It's like someone is pinging the probe and it's answering. The pattern is too tight for random noise." The return signal wasn't a simple reflection. It was modulated, carrying a complex phase shift. It was, for all intents and purposes, a reply. This suggested the object was not just passive, but an active system processing and responding to incoming stimuli. Expert analysis and propulsion theory. You can't discuss these anomalies without bringing in a voice of scientific courage like Avi Loeb. The Harvard astrophysicist, who famously staked his reputation on Oumuamua being alien technology, wasted no time weighing in on the 3I Atlas files. He argued the intercepted telemetry read like a blueprint for an advanced propulsion system. Each 90-second heat pulse and corresponding course correction was perfectly consistent with a massive ion drive or a similar engine. In Loeb's words, if you wanted to navigate through a solar system while managing heat and energy, you would use timed, directional thrust. That is what the data shows. But the most jarring evidence was a fragment recovered by the interceptor's dust collector. A leaked lab memo described a fleck of material with a lattice of silicon and doped phosphorus, arranged in layers spaced at micron intervals. The structure was noted as being radiation-hardened to a degree far beyond current human capability, suggesting it was built for long-duration travel through the harsh interstellar medium. This wasn't just a circuit, it was an artifact from a civilization far beyond our own. So what does this all mean? We have a fictional but detailed account of an interstellar object, 3I Atlas, discovered in 2025. And we have a leaked cache of alleged NASA documents that point to a disturbing conclusion, that the object was a piece of technology. Metallic armor, rhythmic heat pulses that act as thrusters, refined nickel, and structured radio echoes all point to an artificial origin. The most shocking piece of evidence, a microscopic fragment that resembles a computer chip, pushes this story from science fiction into something far more unsettling. While the leak itself is part of this narrative, it forces us to ask a terrifying question. What if our first definitive contact isn't a message but a 26-kilometer machine flying silently past our window? The truth is still out there. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the secrets of science and technology. Thanks for watching InnoVision Tech.